Hi everyone. If you're watching this, then you have chosen the read through with Mr. Greiling. So let's get started. Conduction. Maybe you've heard this word when they're talking about an oven, and that's the first picture we see here. Looks like Christmas cookies. Yum. Let's get going. These cookies look delicious. How did thermal energy help to bake these cookies in the oven? The answer is conduction. What is conduction? Conduction is a transfer of thermal energy between particles of matter that are touching. Thermal energy is the total kinetic energy of moving particles of matter, and the transfer of thermal energy is called heat. Conduction is one of three ways that thermal energy can be transferred. So there's three main ways, and we're just on this first one. Thermal energy is always transferred from matter with a higher temperature to matter with a lower temperature. Pass it on. To understand how conduction works, you need to think about the tiny particles that make up matter. The particles of all matter are in constant random motion, but the particles of warmer matter have more energy and move more quickly than the particles of cooler matter. When particles of warm matter collide with particles of cooler matter, they transfer some of their thermal energy. From particle to particle, like dominoes falling, thermal energy moves through matter. So in the cookie photo, conduction occurs between particles of metal on the cookie sheet and anything cooler that comes into contact with, hopefully not your hand. All right, this is a cool physics video talking about those particles and how anytime we have something hot moving, the movement of particles is going to be so much faster. And if you think about it, it kind of makes sense. If you are super cold and it's winter and you don't have the right jacket, you don't really feel like running around and super happy. You kind of feel cold and you're more still. Where if it's hot out and you're at the beach, so a lot of times the way we are feeling is very well connected to properties of science. Examples of conduction. The cookie sheet in the opening image transfers thermal energy to the cookies and helps them bake. There are many other common examples of conduction. Here are some: hot iron, hot cocoa, hot stew, and wait, not hot snow, but the snow touching your foot, a hot foot in the snow. How is thermal energy transferred in each of the situations pictured in the figures above? Well, if we're looking at the iron, it's going directly to the shirt. The hot cup and the hand they are holding, I've got coffee here. The flame going onto the camp stove. I don't know if you've ever cooked outside like that. It's pretty fun. And then the warmer foot touching the snow. Okay, conduction is the transfer of thermal energy between particles of matter that are touching. Conduction, touching. That's all you got to remember. Thermal energy is always transfers from particle of warmer matter to cooler. When particles of warmer matter collide with particles of cooler matter, they transfer some of their thermal energy to the cooler particles. So some review questions here, but they're just looking for examples, and most of that will be on our option 4 write-up, which isn't too long. I'm going to go to my next one and the last one. Convection. Do you see the water bubbling in this pot? The water is boiling hot. How does all the water in the pot get hot when it is heated only from the bottom by the gas flame? So they're saying you have a whole thing of water, and if you just have heat at the bottom of it, why doesn't the bottom just get hot and then the rest is kind of lukewarm? Well, if you've ever made ramen noodles or boiled some water, you'll know that those bubbles are happening and kind of a conveyor belt of movement of water is moving. Defining convection. Convection is the transfer of thermal energy by particles moving faster through a fluid. So a fluid, something moving, can be a gas or a liquid. Thermal energy is the total kinetic energy of moving particles of matter, and the transfer of thermal energy is called heat. We knew that. Convection is one of the three ways that thermal energy can be transferred. Thermal energy is always transferred from matter with higher to lower. We knew that. So this is the same kind of video with those particles, much like the simulation we had last week with the energy particles. Great way to understand how things would be moving around in a convection style heating. So using hot water in a pot is a great example. When particles in one area of fluid, in this case the water, gain thermal energy, they move more quickly. We knew that, right? They have more collisions and spread farther apart. This decreases the density of the particles, so they rise up through the fluid. As they rise, they transfer their thermal energy to other particles of the fluid and cool off when they get to the top, because they're being exposed to the air. So with less energy, the particles move more slowly, have fewer collisions, blah, 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 and they sink back down. When they reach the bottom, it goes on and on again. And this is what we call a convection current. So I recommend you to have a pot of water boiling on the stove and check this out for yourself. Do it with the parents, and maybe you can make somebody a cup of hot cocoa. Convection currents transfer thermal energy through many fluids, not just water in a pot. For example, convection currents transfer thermal energy through molten rock below Earth's surface. Wow. With magma. The water in the oceans, through air in the atmosphere. So this is a super important one for our whole Earth, and we don't even really see it too much. Convection currents in the atmosphere create winds. Oh, we would have no wind without convection. You can see one way this happens below. The land heats up and cools off faster. And because it has a lower specific heat, therefore the land gets warmer during the day and cooler at night, and then the water does. During the day, warm air rises above the land and cool air from the water moves in to take its place. During the night, the opposite happens. So that we know, if you've ever been out at night, it's a lot cooler, right? And sometimes if you've ever looked at a body of water right early in the morning, you'll see steam. Well, that's because there's the water is warmer than the land around it, and it's creating steam. During the day, in which direction is thermal energy of the air transferred? In which direction is it transferred during the night? Well, reference the figure, and we can see that thermal energy during the day is transferred from the air over the land to the air over the water. During the night, it's the opposite. Okay, our summary. Convection is the transfer of thermal energy by particles moving through a fluid. Thermal energy is always transferred from an area with high to low temperature. Moving particles transfer thermal energy through a fluid by forming convection currents. So I'm sure you've heard the word current before in water, and that's kind of like natural moving of water, but it can also happen in air as well, and magma under the earth. Convection currents move thermal energy through many fluids: molten rock, water in oceans, and air. You know what? I lied. There's one more, because we need to get to our third type of thermal transfer, thermal radiation. Ooh, campfire, put your hands out. You're feeling the heat come out. Someone's warming their hands over a bonfire. They don't have to touch the fire to feel its warmth. Just like you don't have to touch the sun to feel its warmth too. So we've got conduction. Whenever I say conduction, think of touch. Convection. Whenever I say convection, think of movement and the currents moving. And radiation, go like this and think about the sun. So conduction, touch, convection, movement, and radiation, feeling the heat. Those are our 3 types, and that's all what this week is about. The bonfire from the opening image is lots of thermal energy. Thermal energy is the total kinetic energy of moving particles of matter. And the transfer of thermal energy is called heat. We know that. Thermal energy from the bonfire is transferred to the hands by thermal radiation. Now, this isn't like toxic radiation from a nuclear power plant, but that's the same kind of thing because it moves through the air in waves and can reach you. But this is strictly thermal, just has heat with it. When the waves of thermal energy reach objects, they transfer the energy to the objects, causing them to warm up. This is how the fire warms up the hands, and the sun reaches up heats up the surface of the earth. Without the energy radiated from the sun, Earth would be too cold, and Mr. Guyland would have to wear 4 blankets instead of 1. Okay, so radiation, always put your hands out like that, just like this image, and you'll remember it. Radiation is the only way of transferring thermal energy that doesn't require matter, right? Because convection required a fluid, whether it be air or a liquid. But think about all that energy from the sun going through space. There isn't much in space, but still it's coming at us. You might be surprised to learn that everything radiates thermal energy, not just really hot things such as the sun or a fire. For example, when it's cold outside, a heated home radiates some of its thermal energy into an outdoor environment. A home that is poorly insulated radiates more heat than a home that is well insulated. Special cameras can be used to detect radiated heat. So it's where they're losing heat, some bad window or something. And in Minnesota, we see that in the form of huge icicles coming off of roofs and things like that. You're like, how did that form? Well, it's leaking to the attic and it's melting the snow on the roof, and then the snow melts and then it gets to the edge and then it freezes again. So that's how you can tell a home is really kind of wasting energy because you have to pay for it in the winter, right? And yeah, that can be expensive. So I'll let you check out this picture yourself. Same kind of video, same kind of guy. He's going over what does it look like in the chemical form for the thermal radiation. So that's a quick one to check out. So summary, thermal radiation is the transfer of thermal energy by waves. So when you think of waves, go like this. They can travel through air or even through empty space. This is how thermal energy from a fire is transferred to your hands and how thermal energy from the sun gets to the earth. Everything radiates thermal energy, even objects that aren't very warm, right? If you just put a brick that was outside during the winter, and then you had one of those thermal cameras, you would see all sorts of energy leaving the thing with higher temperature, the brick, to the outside temperature. Okay, so let's go to our slides and option 4, pretty quick. Define the 3 types of heat transfer. I've got my 3 types here. List an example for each type of heat energy. Whoo! This might take you like 3-4 minutes. Over here, label each of the 3 scenarios for the heat transfer being described. Write 1 sentence why you think so. So if I'm just saying, if I think that this is convection or conduction, I'm not just going to write it. I'm going to say why. And that should be a full sentence. But there's only 3 of them. Enjoy. Thanks for listening. And I'm signing off here.